Hello, this video is called Master Key to Derivatives because in it we will discuss how to take a derivative of any function. So there is a process to take a derivative of anything, and it usually involves two steps. Step one is to identify the big structure of the question, what it is that we are dealing with. And the big structure depends on how the different functions are connected to each other. And the different choices are, they could be connected with addition or subtraction. They could be connected with a multiplication or division. There could be a function inside a function, or the function may not even be solved for the y. So based on each one of these situations, we will choose the technique that goes with that structure. Then we will look inside and ask ourselves, what is it that we're actually taking derivative of? Is it a polynomial? Is it a trigonometric function? Is it some other function from algebra or calculus? And then we apply the rules that go with that particular function. And then we use the order of operations to simplify, so we use PEMDAS and follow the order of operations to combine like terms, cancel what we have to, and once we do all of the cleanup, that will be the final answer. So this is the process for taking derivative of anything. Now, when we go to the calculus class, we usually get many formulas. There is more than 30 formulas that have to do with derivatives that are often show up on a calculus test. But if we break those formulas up into the main formulas and then the supplementary formulas, then there isn't so much to look at. So let's consider each one a little bit more in detail. So the big picture involves these rules. We can have a power rule. We can be adding or subtracting functions. If we are multiplying, we will use product rule. If we are dividing, we use quotient rule. If we have a function inside a function, we use chain rule. If the function is not solved for the y, we use implicit differentiation. Then we consider what it is that we're actually differentiating. And it could be a polynomial, exponential, logarithmic. All of these are from algebra, are the functions that we have looked at in algebra. Could be trigonometric function or the inverse trigonometric. Could be hyperbolic function or some other function that we haven't even looked at yet. But each one will come with its own formula, and we will use that particular formula to get the answer. So below are 3 examples. Let's see how this technique works on those examples. So here's the first one. And the big picture is we're adding 2 terms. So I'll move this a little bit so we don't look at the next example. So here, we're adding 2 terms. So when we add in 2 terms, we take a derivative of each term separately. So let's write this out. This means we take a derivative of x. I'll change the color. We take a derivative of x cubed, and then we are keeping e to the x, plus we are, with a product rule, we take a derivative of the first times the second, and then we keep the first and take derivative of the second. So now x cubed times e to the x, and we are taking derivative of that. Now the next is derivative of sine x, and the derivative of sine x is just the formula that goes with the derivative of sine x. So now we know what we need to be doing. So we ask ourselves, how do we take a derivative of x cubed? Well, the derivative of x cubed is power rule. So using the power rule, we get 3x to the 2 e to the x plus x cubed. Now the derivative of e to the x is itself. So we just get e to the x. The derivative of sine x is cosine x. So we are done. That's the end of our first example. Now let's look at the second. So here we have a division. So when we have a division, that's called quotient rule. And we're dividing these 2 functions. So let's write the quotient rule and then apply it to this setup. So the quotient rule is just like the product rule, but it has a minus in between, and then we're dividing by the g squared. So let's write out what that actually means. So this means we're taking a derivative of cosine 3x times the bottom function with no derivative minus keep the top function as it is times the derivative of the bottom function, which I will simply indicate that we are doing derivative, but I will do it when I get to it. All divided by x squared minus 1 squared, that's a g function, and g squared. So all I have done is I have taken our rule for the quotient rule and I rewrote it, indicating what I will be taking derivative of and what I will not be taking derivative of, dividing by the bottom function squared. Now let's look inside and see what derivatives we actually get. So here we have the derivative of cosine 3x. Well, what is the derivative of cosine? The derivative of cosine happens to be negative sine. So we get negative sine of 3x times, by chain rule, the derivative of the inside. Because our function is more complex than just x, we also need to multiply by the derivative of the inside, and derivative of 3x happens to be 3. Then we move on to the next derivative. So here we are now taking the derivative of something to the second power, and that is the power rule. So how do we take a derivative of anything to the second power? That would be 2 of that anything to the first, which is 2x squared minus 1 to the first. But since our expression is more complex than just x, we also need the chain rule. So we need to multiply by the derivative of the inside function. What's the derivative of x squared minus 1? Well, that's 2x. So we multiply by extra 2x. Then on the bottom, we have 2 squared. So when we have parentheses, and outside the parentheses is another power, we multiply the powers, and 2 times 2 will become 4. So we have x squared minus 1 to the power 4. Now at this point we notice that each term has the component x squared minus 1, and here also x squared minus 1, and on the bottom x squared minus 1. So if we want to, we can factor out the x squared minus 1 from both of those terms and reduce. So let's do that. X squared minus 1, which leaves me with, on the inside, with negative and then 3 sine. So negative 3 sine 3x times, I had 2 of those x squared minus 1 terms, and I took out 1. So there is still one more term of x squared minus 1 left. Now on the second term, there is only one term like this, x squared minus 1. So once it's outside, we have 2 times 2, that's 4. So we have negative 4x times the cosine of 3x. And on the bottom, we have the x squared minus 1 to the 4th. And we cancel one of these terms, and the 4 turns to 3. And that's it. This is the final answer to our question number 2. So here, this is the final result. Now, let's look at the last example. So here we have the subtraction. Once again, the big picture is we have 2 items that are subtracted one from another, which means we have 2 terms. How do we take a derivative? Well, we take a derivative of each one separately. So let's write it out, and then we will go ahead and do it. Excuse me. So we have the derivative of ln 5x squared derivative, and then we will do the derivative of e to the x cubed. Well, what is the derivative of natural log? The derivative of natural log is 1 over whatever that function is. So 1 over 5x squared. But because our function is more complex than just x, we also need to multiply by the derivative of the inside, which is the derivative of 5x is 10, so derivative of 5x squared is 10x. And then what is the derivative of e to the x? Well, that would be just e to the x. But because we have more complicated function than that, we also need to multiply by the derivative of the power, which is 3x squared. Now we can reduce a little bit and we will be done. 5 goes into 10 twice, x cancels with x, giving us 2 divided by x minus 3x squared e to the x cubed. And that's the final answer to our example number 3. And that's how to take a derivative of any function or any combination of functions. It's a two-step process that works well for any situation. And that's all for this video. If you have any questions, please let me know. Thank you for your time.